In this lesson, we're going to work with linear functions and look at some of the characteristics of them. And for many of you, this will be a review from grade 9 and 10 math that you've done. So when we look at linear functions, the first thing that we look at is their slope. And slope is a way of measuring how steep a line is. And there are a couple of different formulas or ways to look at it. The first one is the rise over the run. The next one is delta y over delta x, which means the change in y over the change in x. And then here's another formula that uses x and y coordinates. So you subtract the y coordinates over the x coordinates. They all mean exactly the same thing. If you think about the change in y, well, that's the difference in two y values. The change in x is the difference in two x values. So all three definitions work the same way. So if we think of a line, and I'm deliberately not putting numbers on here, but if we think of 2 points along a straight line, we can think of the y coordinates and the x coordinates. So for the first point here, point A, its coordinates could be x1, y1. So x1 is over here, x1, and y1 is here, and so this is point A, and that's A's coordinates. Then we have point B, and B's coordinates are x2 and y2. And so this is y2 and this is x2. And so the slope between those 2 points, we can think of it as how much are we going up over how much are we going across. So that's the rise over the run. The change in y over the change in x would give us this y2 minus y1. So that's the difference in our y values over the difference in our x values. So you can see how those formula work together with the definition of slope. We'll take a look at finding slope from straight lines. And if you pick any 2 points on a straight line, you could calculate its slope, because it makes sense, doesn't it, that if it's a straight line, the slope is the same wherever you are. So on this graph, there's a couple of nice points to pick from, and I'm going to pick, and it doesn't matter which 2 you pick because the slope will be the same, but I'm going to pick that point and this point. And I'm going to think about rise over run here for this. So as I go left to right, I'm going up 2 and I'm going over 3. So my slope, and we always use m for slope, and it has to do with a French word métier, which is to climb, or as in going upstairs. So m equals rise over run, or m equals 2 over 3. So I've gone up 2 and right 3. So the slope is 2/3. Let's take a look at the next line here and do the same thing. So let's find 2 convenient points on the line. There's one here. And if I just go up across the line, the next nice point seems to be here. So as I go, and always go left to right, okay? So my slope is rise over the run. So as I'm going left to right, I'm actually going down 1, 2, 3, 4 spaces and going over 7 spaces. So I'm going down 4 and right 7. So this particular line has a negative slope. And if you think about the difference between this line and the previous line, you see that this one goes down as we go from left to right, and the other one went up as we went left to right. So the first one was an increasing function. This one is a decreasing function. We can also use the formula to find slope from 2 points, and we'll use the m equals y2 minus y1, so that means the second y coordinate minus the first y coordinate over x2 minus x1. So if we think of this as x1 and y1, and this one is, x2 x2 and y2, we can plug in those values. So we'll have 7 minus 2 over 7 minus negative 3. So that gives us 5 tenths, which is 1/2. So the slope is 1/2. Always be careful, be mindful of your negative signs. And let's do the slope here for this one as well. So if I consider this my second point and this my first point, I'll go 4 minus negative 1 over negative 2 minus negative 3. So that gives me 5 over negative 2 plus 3, 1. So the slope for this one is 5. Now I just want to show you something, that it really doesn't matter which points you decide is your first point and which one is your second point. If I substitute in, if I do the same example the other way around, where I consider negative 3, negative 1 my first point, and negative 2, 4 as my, as my second point, and negative 2, 4 as my first point, I'll have m equals negative 1 minus 4 over negative 3 minus negative 2. So I have negative 5 over negative 1, which still gives me a slope of 5. So it doesn't matter which order you use for the 2 points, so long as you're consistent, so that the so that your y2 and x2 are from the same point, and your y1 and x1 are from the same point. So we already looked at what a positive slope meant, and really we could say it's when x, or whatever the coordinates, variables are. So whenever your independent variable increases, the dependent variable will also increase. So when x increases, y also increases, gives us a positive slope. So that's any line that goes up as we go to the right, no matter how steeply, okay? A negative slope says that when x increases, y decreases. So as we said, like a decreasing function. So that's anything that goes down as we go to the right, whether it's steep or not so steep. A zero slope. When x increases, y is constant. So a constant function has a slope of 0. That gives us a horizontal line. If you think about the formula delta y, or the change in y over the change in x, it means that when you subtract the two y values, you've got a 0 in the numerator, so you end up with a 0 slope. The last case to look at is vertical lines. So vertical lines that go straight up, if you think about, there's no change in x. Okay, so when there's no change in x, because no matter where you go on the line, the x coordinate is exactly the same, or you could think x2 minus x1 is equal to 0, the slope will be undefined because that's the denominator. Okay, so slope is undefined. So for any vertical line, the slope is undefined. Okay, we're going to look at a few different versions of the equations of straight line. And the first one we're looking at is point slope form, and it uses the slope formula to find the equation of the line. And it's very useful when you're given the slope, and 1 point. So if you think about the slope formula, m equals y minus y1 over x minus x1, what you could do, see how that's so similar to the slope formula? Think of it this way, that I've got this line here, and I've got 1 point, and its coordinates, and I know its coordinates, it's x1, y1. This point, xy, represents any other point on that line. but we know that the slope of it is our rise over our run, okay? So we use this formula then, and what we just do is rearrange the formula. So I'm going to multiply both sides of the equation here by the denominator. So I end up with m times x minus x1 equals y minus y1. And I'm just going to reverse those two sides. So y minus y1 equals m times x minus x1. And that's an equation of the line. An equation of a line will always have a y and an x in it, or at least one or the other of those in it. So let's do an example of this to make it really clear how to do this. Find the equation of a line through negative 3, 4 with the slope equal to 2. So y minus y1 equals m times x minus x1. There's our formula. The y and the x stay where they are. They are representing all the points in those variables. So we plug in our points x1, y1 for the point we're given, and we plug in our slope for m for the for m in the equation. So we have y minus 4 equals 2 times x minus negative 3. And so let's just clean that up a little bit. So y minus 4 equals 2 times x plus 3. So that's slope-intercept form for that equation. However, we often want our equations to have the y by itself, and we want it in simplest form. And we could think of that as function form. We want it to be like y equals and something over here, okay? So to put it in function form, let's work with this equation right above. Let's just add 4 to both sides. So y then equals 2x plus 3 plus 4. So we have it in y equals form, but it's not in its nicest, cleanest form. So let's multiply through those brackets and collect like terms. So we have y equals 2x plus 10. So now to just switch that into function form, f at x equals 2x plus 10. Okay, so these are virtually identical. You'll need the y equals if you're plugging it into the calculator, but you need to be able to think of it in terms of function form as well. So let's do the same with another example. We've got a point here and a slope. So write it in slope point form and then write it in function form. This is a great time to pause, try it yourself, and then check your answer. So I'm going to start with my formula, y minus y1 equals m times x minus x1. Starting with a formula and a new formula without substituting is a really good way to write it out several times so that you end up memorizing it. Okay, so now I'm going to substitute in the values. So y1 is negative 2, so minus negative 2 equals negative 2 times x minus 6. So y plus 2 equals negative 2 times x minus 6. So there's our point slope form. Okay, so now let's change it to y equals form so we can get into function form. So we'll subtract 2 from both sides. So y equals negative 2 times x minus 6 minus 2. Y equals negative 2x. That will give me a positive 12. Minus 2 gives me a plus 10. So now it's in y equals mx plus b form, which we'll get to. Or we could write it as f at x equals negative 2x plus 10. And there it is in function form. Okay, so now let's find the equation of a line where we're just given 2 points. If you think about this, we can use those 2 points to find the slope of that line, and then we can use the slope and one of the points to find the equation. So let's first find our slope. It will be 1 minus 2 over 5 minus negative 3. So that's negative 1 over 8. So there's our slope. And let's use that first point there. Okay, so y minus 2 equals negative 1/8 times x minus negative 3. So y minus 2 equals negative 1/8 x plus 3. So now it's in point slope form. Let's put it in function form. So add 2 to both sides. So y equals negative, and I'm going to multiply through those brackets right away while I'm at it. So negative 1/8 x minus 3/8 plus 2. Think of 2 in terms of eighths, that's 16/8. So y equals negative 1/8 x plus 13/8. Okay, now you might be wondering why I chose the point negative 3, 2 instead of the point 5, 1. And there's a good experiment for you to try. Do the same method, use this point and see what happens. And I'd love to hear your experience from class when you see what happens. One more way that we can use this equation of a line. If we have an x-intercept and a y-intercept, we can also find the equation of the line. So if you think about the x-intercept of 3, so 1, 2, 3, and a y-intercept of negative 6, I want the equation of that line, okay? So to do that, think about what the intercepts mean. We can actually come up with full points for those. If the x-intercept is 3, that's actually the point 3, 0. And the y-intercept is negative 6. That's actually the point 0, negative 6. So now we can find the slope using those 2 points. So negative 6 minus 0 over 0 minus 3, which will give us a slope of negative 6 over negative 3, which is 2. So now I'm going to pick one of the points and put it into our point slope form of the equation. And I'll just use that point, okay? So y minus y1 equals m times x minus x1. So y minus negative 6 equals 2 times x minus 0. So y plus 6 equals 2x. Or if we put it in function form, I'll have y equals 2x minus 6, or f at x equals 2x minus 6. And that's it for this lesson. We will practice these skills in class, and then we'll learn the other forms, the 2 other forms of the equation of a straight line in our next lesson.